So, all right, welcome to lecture number 12. I sent the peer review emails yesterday, so if you handed in the workshop, you should have been getting your groups to peer review by now. If you haven't, contact me. There is a lot of manual work, copy-pasting, so things can go wrong here. But check your mails and you should have gotten 2 groups to peer review and instructions for the peer review also. And as always, it's the group contact person that gets the email and he forwards it to the other team members or group members, and you organize your reviews after that. So one other thing to mention is also that during the workshop next week you will be facing some code, some implementation of something, and continue that implementation and design, and this will be offered in C# or Java. So you can prepare your development environments as you like. So, any questions or anything else regarding this? Nothing? So, okay. Oops. The agenda for today is to take a look at the exam questions and present solutions to them. And basically all of them are based on some pseudocode language that is not that hard to understand. And the first tasks are to make some diagrams, and maybe we should just start with something to warm up, so to speak. So the first task is to construct a correct UML class and sequence diagram giving the following pseudocode. So we create some object here of type candy, and we call that object treat, and we call dobar on that treat object. This is that class, and apparently it kind of like inherits or something from this class, and it has a member of the type foo, and we have the dobar function here, and this object is constructed, and then we call doCandy, that is implemented in this class, and something happens to this argument. So I think possibly the easiest way to start this is to make the class diagram first, because that is the easiest part. So what types do we have and what relations do we have between these types? Well, that should not be so, yeah. No, I think it will be nonsensical names anyway, because there is no meaning to the code anyway, so it would be hard to put any meaning on it anyway. Yeah, but it should not be any problem actually. It just you just need to keep your focus on the task. So you could rename them yourself if you would like to, and just copy paste the code and rename them to something else, if that helps you. Anyway, we have 3 types here. We have the foo class, the candy class, and the foo class. So maybe we should just start by writing those. Was it foo? foo class, candy class, and foo class. And okay, what relationships do we have between them? Maybe the biggest relationship we have here is that candy inherits from foo. So that is the inheritance. We also have an association here because candy has an attribute of type foo called candy. So we should have an association. And we also have the argument to this function in foo, and that would mean a dependency. In foo, we have no relations going out to it, at least. And I think this should be it for the class diagram. Any questions or comments or ideas regarding this? So, okay. A little more complicated is the sequence diagram, but it actually just follow the steps of the code and you will be fine. So the first thing that happens is that a new candy object is created, and this object is called treat. So the create message is sent to the object and it is created. We have actually no constructor implementation here, so we have no code to add to this. So the next thing that happens is do bar is called on this object. No arguments or anything like that. And we check here, okay, what is happening here? We are creating a new object. The first thing that happens, a new foo object is created, and this object is called candy. Something like that, and we have no code in any constructor here, so nothing is happening actually. And then do candy is called. So to what object is this message sent? Maybe that is the trickiest part in this implementation or this diagram. And we could make these little focus boxes if we want to. The do candy message. Where should this arrow go? To itself, exactly, because it is the same object. Even that the implementation is up in this class, the implementation is inherited and it is the same object that is called. So in this case, we would do something like this maybe. Plop, do candy. And what happens here? Well, we send in a, oh, maybe I should have written this also in the, and here it is interesting to know that it is this object that is sent to this function. So when we call bar here on this object, it should go there. We can have a little focus group, and we return true or false, and we are actually done. Wow, that looks amazing. So it is not actually that complicated. Follow the steps of the code. Make sure you know what you're doing. Keep track of the objects, and you will probably be fine. A question here in the chat is, how will you grade this? Can we have any mistakes? It of course depends on what mistakes you make. I won't grade you down for maybe making a small notational error or something like that. If you use a tool to create these diagrams, then maybe you have to do some special notation to just get it somewhat right. For example, in sequence, those web sequence diagrams, you don't send the create message to the box, which is the correct UML notation actually. But I will probably understand what you mean anyway. In this case, I would fail the assignment if you make a call to the wrong object here. If you have not understood how inheritance works and where this object, what object you are actually using, then you will fail the assignment. So it very much depends on the mistake you make and how serious it is. I would probably fail you also if you make serious mistakes in the arrows here in the class diagram. For example, doing a interface realization between foo and foo instead of a dependency. That would change the meaning of the diagram in such a dramatic way that, okay, it would mean something completely different. So, and there are possibly 4 arrows for you to handle, and it should not be that much really. Questions on this assignment? Was it simple? Yeah, it should. These first assignments should be pretty straightforward. It is just look at the code, take it step by step, and you should be fine. One thing to note also is there won't be any score or points or anything on the exam. You will just get a pass or fail on it, and you will probably get 3 tasks to solve within your time frame, and you need to have the correct answer on 2 of those. So, okay, let's continue. Maybe we should do another one just to continue our warm-up. And I think that the way to go is the same way. We have, can take a look at the code first here. We have the candy object is created. This is the candy class. It kind of inherits from the food class. It has an argument here. DoBar is called. A function getCandy is called, and bar is called for on this object. So it will probably look very much similar to what we just did, but let's take it once more. So we have a foo class. We have a candy class. And we have a foo class. Can take a look at the foo class first. No relationships, nothing created, nothing used. It stands on its own, no dependencies going out from it. Can take a look at the candy class. We once more have this inheritance. So something like that. We also have an argument, no, not an argument, an attribute of type foo called candy. So we should have an association, and the role name should be the name of the attribute. Otherwise, we don't have anything more to offer there. And we have the foo class, and it creates an object of type foo. So it should have a dependency like that. So we have the same class diagram actually as before. But rather than getting an argument in this function, we create an object. And I suspect that the sequence diagram will look quite similar. We start off by creating an object called treat of type candy. Create. We don't have any constructor really, so it is just created there, and we can then use it. Maybe I should at least try to make this. And then DoBar is called on this object. What happens in DoBar? getCandy is called, and once more it is important to know that, okay, this is inherited from this foo class, but it is the same object. So we should have this. And what happens here is that the new foo object is created. And we could call it candy. Oops, it should be a dashed line. So that is returned. And then bar is called on this object. And it returns, and we are done. So something like that. I get a question here in the chat. If we use web sequence diagrams that doesn't support anonymous calls, can we fake that by naming the class anonymous? That is perfectly fine. Anonymous client, anon client, anon or something like that, just so that we can understand that it is this example code calling from the outside, so to speak. So that will work just fine. Any questions? Super clear? Maybe we should leave this this last class diagram and sequence diagram as an exercise for you to do, so you can do it for yourselves instead. But it is probably quite similar to the others. Make a class diagram first, follow the calls of the objects that are made, make sure you are calling the right object, and you should be fine. Oh, we had 2 of those, so you have 2 exercises. So, those tasks I think are quite simple. If you have some kind of knowledge about the class diagrams, the notation, and this translation of code into sequence diagrams, you should be fine. And this is something that you have also practiced, I hope, in workshop number 2. So if you have participated in those workshops and actively participated in them, you should not have a problem with this kind of task anyway. So we now face a couple of maybe more interesting and challenging tasks, and the problem is you have some functional code here, but it has a glaring problem. The task is to identify the problem and refactor it using a standard OO method. You should update the code and make a correct UML class diagram over your solution. So we have an example of the current usage. We have 2 types created. One object of type foo and one object of type bar. And do stuff is called on these, and we have an interface with this do stuff method, and we have these two types here then. We have the foo that implements this interface, so it has to do stuff here, and it is a bunch of code. And you have these calls that always must be done first on a number of other types we have here. And in the class bar, we kind of like have the same thing here. So we have some code here, and if you look carefully, you can see that it is exactly the same code here. And then we have some unique code in this function below, and this is also some kind of unique code here. So, what is the problem? Yeah, the problem is repeated code. So we have code here that, first of all, it is repeated between two types. And a secondary problem you could think about is, okay, we have this requirement that these calls must always be done first. So if we add another implementation of this interface, this kind of a code must still be made first. So that is also something that we maybe should address in our design to make sure that this code is always called first. So, okay, the solution to this duplicated code, what is it? What do we do if we have duplicated code in two classes? A base class, and push the code that is common to these types into this base class. So let's do that then. And I will probably just use Notepad here. So maybe we should have this let's see, maybe we should just call it the base. Really huge tab. So these calls must always be done first. You can start by copying this. Oops. And to do this, we need some objects here. We need the candy one object, and we need the wonk object up here. So we add these. Something like that. So this code is now functioning, and we can remove this code from this type. Oh, no, I can't. So the foo class will look something like so. We remove those two arguments, attributes, I mean. We can remove this code. And we can add the base class here, and we can kind of like just make a call parent do stuff, or maybe we should so something like that. And then we have this class here, the bar class, and it will be something similar. Something to notice here is the naming of this object also need to change, because it is actually candy 1. So something like this. Something like that, and we can remove both these and add base here. So maybe this is the first step, at least, that solves the problem of the duplicated code here. Any questions or comments on this? Yes, just some way of calling a method in your parent class. In some languages you specify that you want to call the parent class superclass, it's called something sometimes. If you you could probably just do it like this. No, since we are inherent from that type. Yeah. Yeah, we can continue actually to refine this a little bit more. So we will do that in a minute and take a look at it. Fixing the class with pseudocode is quite okay. So you don't need to translate it to C# or Java or something like that, as long as we can understand what you mean and it's fairly obvious. It is fine to just do it in this pseudocode way. So, but at least we have fixed the most urgent issue here with the duplicated code. We have moved that up to a parent class. But as you see, if we add more implementations of this interface that are supposed to work in the same way, we still need to make sure that we don't forget to do this. Yes? Oh, no. This is where you need to look out a little bit. You see this? Here we work on one candy object. Here we work on another candy object. And here we work on this candy object called candy2 in this type. And we work on the same object here. So that is something you need to look out for, so that you don't use another object suddenly. So, but we can address actually this issue also by refining our design and say, okay, it is actually this type that should implement the interface. So it will actually do stuff here. And it will do all the stuff that is mandatory to do, so to speak. And anyone who inherits from this type will have a chance to do so afterwards. So a design like this would actually be even better, because anything we inherits from the base class now, we will get the mandatory stuff done. We don't need to remember to do that or call something in the parent class. And we will have the chance to do our specific stuff, and we will get a compilation error if we don't implement this function. So the questions here, is it possible to declare do stuff final so that it cannot be overridden and changed? Yeah, yeah, possibly. We have not been talking so much about these functions to finalize operations, because it becomes a little bit more language specific. Not all languages has the ability to do such stuff, so I don't think it's really necessary. Another question is, why would you need the interface? Well, the interface is probably there because we have some application on the outside that use this interface in some way. And you could also maybe imagine that, okay, we can have other implementations of the interface that does not inherit from this abstract base class here. Another question, would it be bothersome to create actual names on the real exam? These kinds of names make me really confused, even though the task is quite simple. If you have a problem with the names, rename them yourselves in your solution to something that you like in that case. The problem with assigning some real names is that then they kind of like get their own meaning, and sometimes the solution and this design does not point to that meaning that you get in your head when you use real names. So I thought it would actually be better to just use these nonsensical names, but you could call them X, Y, and Z or something like that instead. And also, it is an exercise in looking carefully at the code, because code you get to look at will probably not be nice in all cases, and things will be named funnily and oddly. So it is an exercise in that also. So look carefully at the code that is written. Questions? I will probably save this, I think. Oh. Is it number 5 or something like that? Ja.
Ja, jag bara tänkte lite på den här uppgiften.
Ja.
Räknar du ett visst antal poäng per uppgift, eller är det bara godkänt eller inte godkänt uppgifter? Hade det varit okej till exempel att bara fixa första armen där?
Ja.
Hade det varit en godkänt?
Yeah, I would not mark that as a failed task, because the most pressing issue is to fix the missing the duplicate code. That is the glaring problem, I think, in this task. So possibly you will get some kind of bonus reward if you fix this other problem also using a nice design. The question was, how is it enough to just fix the problem with the duplicate code, or do you need to do this special design also to get a correct answer on the task? And I would, the glaring problem is definitely the duplicate code, so that is what you should take care of first, at least. And actually, this is another design pattern that we have used here that is called the template method. So you could look at that up also. Isn't wonky missing? I think we have it up here. Yeah, the class, I don't know. Yeah, they are just some kind of dummy code, so those won't need to change. We also have a developer note here. There is a high probability that we need to add more classes that realize the interface in coming sprints. So, yeah. Yes?
Since this isn't real programming code, like what kind of language do you want us to program in, or like what do you want us to strive for? Because there's so many different ways to show inheritance and abstractions and privacy and...
Yeah. So the question is, as this isn't real programming code, what is the notation or code that you are supposed to use? And if you, yeah, for me it is fine if you make it obvious just what you mean.
Because like you can mix.
You can mix, absolutely. I think this pseudocode is kind of a mix between C++ and Java and C#. But I wouldn't mind if you said implements up there, or that would be the most UML-ish name at least, but something like this would be fine, something like this would be fine, as long as I can understand what it is that you mean.
So notation is not...
Notation is not that important, and as you can see, you are probably missing a couple of... And I will fail you for that, so be really, really careful. No, I won't fail you for that. But actually, coding on paper is really a good way of learning how to code. And I remember we did a lot of tests coding on paper when I was in school, writing long programs, paper up and paper down. And you failed if you got the syntax wrong. So that's a good exercise, not trust in compilers or IntelliSense and stuff like that all the time. And it was quite frustrating when you realized you had made a mistake somewhere and you just needed to, okay, I must just erase half a page of code and try to cram in the corrections I wanted to do. So, okay, any questions on that? No? Let's move on then. We have another task here. This code is functional but has a glaring problem. Your task is to identify the problem and refactor it using a standard OO method. You should update the code and make a correct UML class diagram over your solution. I have not made it. We did not make a class diagram for this, but it should not be that difficult for you to do, so I won't be doing it. One thing that I would actually appreciate is so if you state the problem at first, that could definitely help both you and me, so that I know that you have identified the correct problem. So do that, please. The problem is duplicate code and the enforcement of mandatory code order. And just a sentence like that will also help me to understand what it is you have at least been trying to do in your code and diagram. And that will, of course, make it also easier for me to interpret what you are trying to do in your code if you make some mistakes. I can at least know that, okay, given a compiler and the development environment, this person would probably get this right. So, okay, let's take a look at the other problem that we have. We have this foo that is created and do stuff is called. And we send two arguments here, 1 and 3. And in this class foo, you have a type of algorithm and type of algorithm number 2. And depending on what you send into the constructor, these types of algorithm variables are set. And then when do stuff is called, we switch on the type of algorithm number 1 and we call this and we get a result. And we use this in algorithm number 2. And we use the switch once more on the type of algorithm attribute and call a number of algorithms, and then we get a second result and we return this result. And we have the implementation of all these algorithms here. So you can think about the problem and possible solutions during the break. So we will have 15 minutes of a break now, and you can try to figure this one out.